I don't feel like doing anything today.
I feel nauseous, believe me.
I just don't feel like doing anything.
Had to work hard, struggle just to be me.
जैसे है चलने दो. Let it be.
Had to rise up just so they could see me.
So what? सच में आज कुछ करने का मन नहीं कर रहा.
But the only thing in life that has meaning
What's this?
are the things you gotta work for, believe me. Take into your hands a plan, your own hands can land your own brand, and damn,
So at times we all feel like not doing anything. At times क्या? मुझे तो हमेशा ही लगता है. Now what is that thing that forces you to do something? To create something today. If you do not have any aim in life, then let it be. You will spoil all your days. Days will go, weeks will go, months and years, and you will waste up your time, your life doing nothing. There has to be some aim in your life. Got it? There has to be some aim in your life. If not aim, at least try to improve yourself. Try to become a better version of yourself with each passing day. So I didn't feel like shooting a video today. I'll waste my time watching TV, doing nothing, sleeping. But then I decided, you got one life, you don't even know when it will end. Let's create something valuable today. Better not waste your time. At least try to become a better version of yourself with each passing day. Let us start with the video. Now you all must be knowing the concept of uniform motion, wherein we say that acceleration is 0 and non-uniform motion is the one where you have some kind of an acceleration. See, now if I am not doing anything, if a body is at rest, some external force is required to move this body. If I keep it on a table, some external force will be required to move this body. On the other hand, if this body is moving, I need some opposing force to stop this body. This thing you all know. So what is the difference between these two statements when I say I do not require any external force or I do not require any net external force? What is the difference between these two statements? We need to understand. एक का मतलब है मुझे कोई external force नहीं चाहिए. दूसरे का मतलब क्या है कि मुझे सब फोर्सेस को कैंसिल होने के बाद कोई एक्सटर्नल फोर्स बची हुई नहीं चाहिए, कि सब फोर्सेस लगने के बाद कोई एक एक्सटर्नल फोर्स ना बचे, ऐसा आई वांट. टेक सम टाइम एंड थिंक अपॉन इट. तो दोनों का मतलब क्लियर है? ठीक है. तो अब अगर ये, इसको क्या कहते हैं, मैंने स्विंग मशीन से निकाला है. तो इफ दिस थिंग इज sitting nicely over here, so this is said to be at rest. This is said to be at rest, and I can say that there is no acceleration. Now what if I move this on a table? After some time I'll notice it will automatically stop. That means there was some kind of a force acting between this wheel and the table that forced this wheel to stop, to ultimately stop. You know that that force is the force of friction. So what I conclude was some external force was required to stop this. Now if at all I try to move this wheel on the table in a manner like I'm providing a force which is equal to the force of friction, such that the motion of this on the table is a uniform motion. In that case, the net acceleration is 0. Acceleration is 0. I mean to say that I do not require any net external force. But you will be saying that I am applying some force, only then I am saying that acceleration is 0. But the concept here is that I am providing an external force that is equal to the force of friction, so that my net external force is 0. Net external force is 0. So that means in order to keep a body in uniform motion in a straight line, this is also important. Why am I saying in a straight line? because acceleration is change of velocity with time, and velocity is a vector. The change in velocity includes the change in its magnitude as well as a change in its direction. So, in a straight line, word is important. So, I mean to say that no net external force is required to keep the body in a uniform motion. To keep a body in a uniform motion, I require no net external force. मुझे external force इस body पे लगानी पड़ी to cancel the force of friction so that net external force is 0. So that means I can conclude that the state of rest and the state of linear uniform motion are equivalent, like they do not need any acceleration. Talking a little bit about the history, there was a Greek thinker, Aristotle, who said that an external force is required to keep a body moving. Today we know that most of his ideas were wrong, but where is this statement wrong? So the problem with Aristotle's statement was that he had given this statement using some of the practical experiences. You know that an external force for the case of uniform linear motion is required only to counter the force of friction, and no net external force is required to keep a body in the uniform motion. So it was Galileo who studied the motion of the objects on an inclined plane, and he concluded that going down from an inclined plane an object got accelerated, and moving up an inclined plane the object faced some sort of a retardation, and when the plane was of zero slope, that is a horizontal plane, and if the plane is made smooth, an ideal situation, then the object would not have retardation or acceleration. The object won't have any of these, which was the case of a uniform motion. So thereafter he concluded that the state of uniform motion in a straight line requires no acceleration. A body does not change its state of rest or of uniform motion in a straight line until and unless it is compelled to change that state with the help of some external force. Resistance to change. This is resistance to change. Thereafter Newton worked on Galileo's ideas and gave his laws of motion that go by his name. So Galileo's law of inertia, this is the law of inertia, was his starting point, and this also became the first law of motion, which states that every body continues to be at rest or in a uniform motion in a straight line until and unless it is forced to act otherwise, until and unless it is compelled by some external force to act otherwise. So if net external force acting on the body is 0, its acceleration is 0, and the other way around, acceleration can be non-zero if and only if there is net external force acting on that body. An example of this resistance to change, that is also called inertia, is also encountered in our day-to-day lives. For example, if you are sitting in a car, a moving car, and suddenly the brakes are applied, you are thrown in the forward direction. So why is it happening? Because this is a concept of inertia. जैसे थे वैसे ही रहने दो, चेंज क्यों किया? जैसे था वैसे चल रहा था, तो मतलब कार चल रही थी, ठीक था, तुमने ब्रेक क्यों लगाई? तो what happens is that your body got used to the situation that the car is moving, and so you are moving. So when the brakes are applied, there is a force of friction acting between your feet and the floor or the bottom of the car, and it is that friction that is preventing any relative motion. So what happens is that the force of friction is able to stop your feet from having any relative motion. But however, since we are not rigid bodies, we are deformable bodies, we are not perfectly rigid bodies. Our body parts can have relative motion with respect to one another. Our hands can move relative to the feet. So what happens is that while the feet stopped, the whole body was in a state of moving in the forward direction because of the law of this inertia, the resistance to change. While the feet stopped, the body couldn't, so we tend to fall in the forward direction. Similarly, you must have seen that when traveling, for example, in a bus, if you are sitting in a train or a bus, then you must have experienced this thing that if suddenly the bus or the train moves, you tend to fall backwards. you tend to fall backwards. ये थोड़ा ज़्यादा हो गया, but इसी तरह कुछ. तो what happens in that case, because of the law of inertia, your body is tending to be in a state of rest, like nothing is moving, you are not going anywhere, but suddenly that vehicle tends to move. The force of friction acting between your foot and the floor of that vehicle will tend to carry you along with the vehicle. However, your upper body is not ready to face the situation. It is not ready to change its mind. So it is resting in the same position as earlier. However, the feet get carried away in the forward direction. So you fall backwards, and it is because of the other muscular forces that are acting that you are able to carry yourself with grace. Make sure that nobody makes fun of you. Finally, you do not keep on falling backwards or in the forward direction. So the restoring muscular forces come into action, and they are able to stop this relative motion, and they are able to bring your body back to rest. So that was all about the first law of motion. I hope you liked this video, and I'll be back with my next video. Till that time, this is Pooja saying goodbye, and take really good care of yourselves. And let me edit this video now so that I can post it for you.